So hello students, in today's video lectures I'm discussing about the three types of problem that we are expecting in the INSEP examination from unit number 2. The first problem will be on entropy and the information gain. So problem will be for 7 to 8 marks, and we are expecting at least 4 features in the examination and one target column. So the problem is something like this, and uh, we have to design here a decision tree. Okay, so for solving this problem, first of all, we have to take the target column. Here the categorical data is given in terms of yes and no. Calculate the number of yes. So here yes is 9 times and no is 5 times, and total observations are 14. So the probability of yes is 9 by 14, and the probability of no is what? It is 5 by 14. We have to calculate the entropy for the target data set, or that is the entire data set. So here the formula is the minus P1. So here the formula for calculation of the entropy is the minus P1, okay, log to the base 2 P1 minus P2 log to the base 2 P2. Okay, so in this solution, this plus sign it is used for the yes, and minus sign it is used for the no. You just concentrate on this number only. Okay, 9 and 5. So 9 is coming, yes is coming 9 times, and no is coming for 5 times. Okay, so here the total observations are 14. So 9 is coming, the yes is coming 9 times. So probability of the yes is 9 by 14. No is coming 5 times. If you count here the no, and total number of observations are 40. So probability of no is what? 5 by 40. So this is our P2, this is our P2, and this is our P1. So the entropy of the entire data set is minus 9 by 14 log to the base 2 9 by 14 minus 5 by 14 log to the base 5 by 14. So this comes out to be 0.94. Now we will take individual columns. So first we'll take the weather. So in weather we have sunny, we have cloudy, and we have rain. So these are the three subsets are there. We'll take one by one, one data set at each time. So first we will concentrate on the sunny. So the sunny, the count for the sunny is coming 5 times. So n is equal to 5. Sunny is coming 5 times, and then in sunny we have to see how many times yes is there and how many times no's are there. So in sunny, 2 times yes is there and 3 times no's are there. So total count is 5. So probability of yes is the 2 by 5, and probability of no is what? It is 3 by 5. Okay, you have to just take the value of yes divided by the total number of that occurrence of that particular child data set. So sunny is coming 5 times, yes is 2, so 2 by 5, no is 3 times, so 3 by 5. Okay, and then we have to apply the same formula. For cloudy is coming 4 times in the column, yes is 4 times and no is 0 times. So here the probability of yes is 4 by 5, 4 by 4, because cloudy is 4 times, yes is 4 times, and probability of no is 0 by 4. And then we have to apply the entropy formula. The n is occurring for the 5 times here. In the rain, yes is 3 times in the rain column. The yes is 3 times and no is 2 times. Okay, so probability of yes is 3 by 5 and probability of no is 2 by 5. Okay, after calculation of the entropy for the individual data set, then we have to find out the information gain. Information gain is equal to entropy of the total data set that we have calculated here, 0.94, minus the weighted average multiplied by its entropy. Okay, so weighted average for sunny is the occurrence of sunny is 5 out of total observations are 14. Okay, so this is total observations are 14. So occurrence of sunny is 5 by 14 multiplied by its entropy, so 0.97. Then cloudy minus 4 by 14 multiplied by 0. Then 5 by 14 multiplied by 0.97. So we will get the information gain as 0.246. Okay, so this is for the first column. Then take the next column, temperature. In temperature column, we have hot, mild, and cool. So 3 subsets are there. Count how many times hots are there. So hot is coming 4 times. Okay, then mild is coming 6 times, and the cold is coming 4 times. Okay, so now in hot we have to check how many yes are there. So 2 yes. So probability of yes is 2 by 4. 2 no's. The probability of no is 2 by 4. Okay, then we have to calculate its entropy. mild is coming 6 times, 4 yes and 2 no's. So 4 by 6 yes, probability of yes, and probability no is 2 by 6. Okay, that is P1 and P2. Then cold is coming 4 times, so 3 yes and 1 no. So 3 by 4 yes, and probability of no is 1 by 4. Okay, 1 by 4. Then information gain, we have to find out the information gain. So entropy of the whole data, that is 0.94. Okay, minus the weighted average for the hot. Weighted average for the hot, so 4 divided by 14, because total observations are 14, multiplied by its entropy. So this is 1. 6 by 14 multiplied by its entropy. 4 by 14 multiplied by its entropy. Okay, so information gain will come for the temperature, it comes out to be 0.029. Now for humidity, we have here on two subsets, one is high and normal. The high is coming 7 times and normal is coming 7 times. So in high, 3 S are there, 3 S, 1, 2 and 3, and 4 no's are there. So probability of yes is 3 by 7 and probability of no is 4 by 7. So P1 and P2, calculate is entropy. Normal is coming 7 times, 6 yes and 1 no. So 6 by 7 and 1 by 7. Probability of yes is 6 by 7 and probability of y is, no is 1 by 7. Information is entropy of the total data set, so that is equal to 0.94 minus the weighted average for high, so it is 7 by 14 multiplied by 0.98 minus 7 by 14 multiplied by 0.59. Okay, so answer is 0.15. Information gain for the humidity is 0.15. Similarly, for the wind, we have the strong and weak wind. Strong it is coming 6 times and weak is coming 8 times. So in strong, this is 6 times, this is 8 times. In strong, 3 yes are there, so probability of yes is 3 by 6. 3 no's are there, so probability of no is 3 by 6. So P1 and P2. In case of normal, the yes are 6 times, so 6 by 8. P1 is equal to 6 by 8, and probability of no is 2 by 8. So this is for 2 by for no, and this is for yes. We have calculated the entropy. Information gain for the wind is entropy of the whole data, that is 0.94 minus weighted average for strong, so 6 by 14 multiplied by 1 minus 8 by 14 multiplied by 0.81. So this comes out to be 0.0478. So these are the information gain for weather, temperature, humidity and wind. In case of the information gain, okay, we have to select we have to select the column which is having the higher information gain. Okay, so information gain must be higher. So out of this 4, so weather is having the highest information gain. So we will select weather as the decision node, first decision node. So we have selected the weather. In weather we have sunny, cloudy and rain. Out of that, the cloudy, all the output is yes. So directly we got the answer here. Okay, so if you see the cloudy, so in weather for the cloudy, okay, so these are all yes. So cloudy yes, here cloudy yes, here cloudy yes, and here. So the output is yes there. Okay, so we got the output for the one decision node. Now the 2 decision nodes are remaining, sunny and rain. So we'll first select the sunny. So select all the rows for the sunny. So we got here 1, 2, 3, 4, 5. So 5 rows for the sunny. Now sunny is our parent node. Okay, so we have to calculate first the entropy for the parent node, that is for sunny. So in sunny, that is our parent node. 2 yes are there and 3 no's are there. So total 5. Total 5 observation. Out of that, 2 yes, that means probability of yes is 2 by 5, and 3 no, that is probability of no is 3 by 5. So P1 and P2. So we'll get the entropy for the now the new data set, okay, with 5 observations, so 0.97. Now then we have to select what? The temperature, humidity and wind. We have to repeat the same procedure for temperature, humidity and wind. Now in temperature we have hot, mild and cool. In humidity we have high and normal, and in wind we have weak and strong. So for the temperature, the hot is coming 2 times. Out of that, yes is 0 and no is 2 times. So 0 by 2 and 2 by 2. Okay. Then in case of the mild, the mild is coming 2 times, 1 times yes and 1 times no. So probability of yes is 1 by 2 and no is also 1 by 2. the cool is coming only one time. Yes is 1, no is 0. So probability is what? It is 1 by 1. Okay, 1 by 1. So the information gain is what? Entropy for the sunny. Now here in this case it is 0.97. So here this is 0.97, that is for the sunny as a parent node, minus hot, the weighted average for the hot is 2 and total observations are 5. Okay, so 2 by 5 multiplied by 0. For mild it is 2 by 5 multiplied by 1, and for cool it is 1 by 5 multiplied by 0. Okay, multiplied by entropy. So we'll get here 0.57. For humidity we have high and normal. The high is coming 3 times and normal is coming 2 times. For high, yes is 0 times, no is 3 times. So probability of yes is 0 by 3. So the 0 by 3, and no is 3 by 3. So 3 by 3. So it is 0. For normal it is yes is 2 times and no is 0 times. So 2 by 2. Okay. So wherever the one data set is 0, so entropy becomes 0. And when both the data set is equal, so then the entropy is 1. Okay, that you have to remember. Okay, when one data set is 0, then entropy is 0. When both the data set is same, the entropy is 1. Then wind, we have strong and weak. The strong is coming 2 times and weak is coming 3 times. In strong, 1 yes, 1 no, 1 by 2 and 1 by 2. Both are same, so entropy becomes 1. In weak, 1 yes and 2 no, so 1 by 3 yes and 2 by 3 no. Here the weighted average for strong is 2 by 5. Okay, your total observations are 5, so 2 by 5 and multiplied by 1, and 3 by 5 multiplied by 0.918. So we'll get the entropy as 0.019. So when we consider sunny as a parent node, so when we consider the sunny as a parent node, so temperature, humidity and wind, we have calculated the information gain. Again we have to select the highest information gain. We have to select highest information gain in terms of in case of the information gain. So here humidity is having the 0.97. Okay, so we will select the humidity, and in humidity we if we check the humidity. Okay, so if we check here the humidity, so in case of this the humidity, so all high is having it is having yes. Let us check here. Okay, for all the for all the humidity. Okay, for all the humidity, let us check here. So for all the humidity, so here for high, all the high it is no, and for normal it is yes. Okay, so we got the final answer. High it is no and low it is yes. And this we already covered in the first part, the first decision node, that is cloudy and yes. After that we have selected sunny, and in sunny we have found out the next decision node out of temperature, humidity and wind. We have selected humidity because it is having highest information gain, and then we got the final output as yes and no. Now the rain is remaining, so now we have to split the rain. So select all the rows of the rain, and in case of the rain we have 1, 2, 3 yes and 2 no's. So the entropy, so 5 observations. So now rain is our parent node. Our total number of observations are 5, 3 yes and 2 no. So 3 by 5 and 2 by 5, P1 and P2. So yes is 3 by 5 and no is 2 by 5. So now in case after that we have the children node as temperature. So hot is not coming. So there the hot is not there in the temperature. If you see here in temperature, the hot is not there. Only mild and cool is there. So hot is not there. So the probability is what? 0 by 2 and 0 by 2. Okay. So because it is not coming, so you can neglect this total term. Mild is coming 3 times, 2 times yes, 1 time no. So probability of yes is 2 by 3 and probability of no is 1 by 3. So 2 by 3 and 1 by 3. Cool is coming 2 times. So 1 yes, 1 no, 1 by 2 and 1 by 2. So 1 by 2 yes, 1 by 2 is no. Information gain, so entropy for now rain, it is 0.97 minus we don't require the first term, so the 3 by 5 multiplied by 0.918. The weighted average is for mild is 3 by 5 multiplied by its entropy 0.918. The weighted average for cool is 2 by 5 2 by 5 multiplied by the entropy 1. So we'll get this 0.019 as a information gain. For humidity, the high is coming 2 times and normal is coming 3 times. Yes is 1 time, so 1 by 2. No is 1 time, so 1 by 2. In normal, the yes is coming 2 times, so probability of yes is 2 by 3. No is coming 1 time, so probability is 1 by 3. The weighted average for high is 2 by 5. 2 by 5 multiplied by the entropy 1. For normal, the weighted average, the average is 3 by 5. 3 by 5 multiplied by 0.918. So the information gain comes out to be 0.019. Similarly, for wind, the wind is the strong is coming 2 times and weak is coming 3 times. The strong 0 yes and 2 times no. Now since one data set is 0, so the entropy for this data set is 0. If both are same, then entropy is 1. For weak also, only yes is there, no is 0, so entropy is 0 here. Now the weighted average for strong is here it is 0.97 minus weighted average of the strong, so 2 by 5 multiplied by 0 minus weighted average for weak, it is 3 by 5 multiplied by 0. So it comes out to be 0.97. So now we got the information gain for temperature when we consider rain as the parent node, humidity and wind. Again, we have to select the information gain which is having the highest information gain. Highest. We want now in this case information gain, we want highest information gain. So it is for wind. So we'll go for the wind. Now in this wind we have two subset. One is strong. When there is strong wind, don't play. When it is weak wind, it is you can play here. Okay, so that we can select from the. So in wind, when it is weak, you can play. Weak it is yes, and for strong it is no. Okay. So now this is the final decision tree for the decision tree problem for using the entropy and the information gain. So, okay. So this is the first problem. Okay. Now the same problem we will solve using the another concept. So that concept is called as the Gini index. Now what is the Gini index? So Gini index is just the measurement of the impurity. So when Gini index and it is calculated, it is having the value of 0 and 1. When the Gini index is 0, so that means the data set is pure. That is impurity is not there or mismatch is not there. And when it is 1, so it is highly impure. The value between 0 and 1, so it comes under the medium impure. Okay. The formula for calculation of the Gini is very simple. 1 minus summation of the probability square. Okay. So we have calculated the probabilities. We have to just minus it from 1 and we will get the Gini index. Okay. So that we will calculate. Now we will take the same problem. So we have the 4 rows: weather, temperature, humidity and wind, and this is our target output. So we will first consider the target output. So play football, we have count the number of yes, count the number of no, probability and total observations are 14. So probability of yes is 9 by 14 and probability of no is what? 5 by 14. Okay. Now once you got the probabilities, now calculate the Gini index. Okay. So how to calculate the Gini index here? So 1 minus probability. So this is 9 by 14 square minus here this is 5 by 14 square. Okay. So if you calculate this value, so what we will get here, the answer is 4. We will get here 0.46. So this is for the parent. Okay, or total data set. Okay. So it is just the simple one. We already calculate the probabilities in entropy and information gain also. So here you have to use the formula. The Gini index is equal to 1 minus P1 square minus P2 square. Okay. So we'll get the Gini index for the parent node. Okay. So that we have calculated. Now let us take all the features as a column. So in weather we have sunny, cloudy and rain. We will first consider sunny. Count how many sunnies are there and count how many yes and no's are there in front of this sunny. So sunny is coming 5 times. 2 yes, that means probability for yes is 2 by 5 and 3 no's. So probability of no is 3 by 5. So if you calculate here the Gini index, so it comes out to be 1 minus. So this is probability of yes, so 2 by 5 square minus probability of no, so 3 by 5 square. Okay, so if you calculate this value, so it comes out to be 0.48. Similarly, You count how many cloudy are there. So cloudy is 4 times. Out of that, yes is 4 times. So probability of yes is 4 by 4, and no value is not there. So no is 0. So 0 by 4. So if you calculate the GI for this, so 1 minus, so this is 4 by 4 square. So it comes out to be 0. Okay, so it is just similar to the entropy also. Okay, so if you calculate the entropy also here, when one subset is 0, so you'll get the entropy as 0. Similarly, GI also will get the 0. Now calculate the number of rains. Rain occurrence is 5 times. Out of that, 3 is yes. So probability of yes is 3 by 5, and 2 times no. So probability of no is 2 by 5. So if you calculate here the GI, so it is 1 minus probability of yes square minus probability of no square. Okay, so if you calculate this value, so this value comes out to be 0.48. Okay, after that, here in case of the entropy and information gain, we have calculated first entropy and then we have calculated the information gain. Okay, now here we have to calculate the GI of what? The weather. Okay, so here you don't have to consider the parent. Okay, so parent value, only consider weighted average. Okay, so only consider the weighted average multiplied by its the GI of the children. So here we don't have to minus anything from the parenthood. Okay, we have to only consider weighted average and the GI of the children. So what is the weighted average for the Sunny? So Sunny is 5 times. 5 times out of what? 14. Total observations are 14. So 5, 5 and 4. This, okay, multiplied by 5 and GI of this Sunny is what? It is 0.48. So this is 0.48 plus weighted average for cloudy. So this is 4 times occurrence out of 14 multiplied by 0 plus rain is coming 5 times. So 5 divided by 14, and GI of rain is what? It is 4. It is 0.48. So GI of the weather, it comes out to be 0.34. Okay, so this is the value for the GI of the weather. So see the difference between the entropy and information gain. In information, while calculating the information gain, we have minus this weighted average multiplied by entropy value from the parent entropy values. But here, in case of the GI, we don't have to minus anything from the parent value. Just multiply the weighted average by its GI value for that particular feature. Okay, so we don't have to minus anything. Just multiply the weighted average multiplied by GI here. Okay, so this we are done for the one column. Now let us take the second, temperature. Now in case in case of the temperature, we have hot, mild and cool. Okay, so hot is coming, the hot is coming 4 times. Okay, hot is coming 4 times. So the probability of yes, so if you calculate here the probability, so 1 minus probability of yes is what? Yes is 2 times out of 4. Okay, so here you will get the 1 minus v1 square, and then probability of no is what? It is again 2. So 2 by 4 square. So if you calculate this value, so this value comes out to be the value comes out to be 0.5. Okay, if you calculate this value, so it comes out to be 0.5. So mild is the mild is coming 6 times. Okay, so mild is coming 6 times. So this is 1 minus. So in 6 times mild, 4 times it is yes. So this is 4 by 6. Probability of yes is 4 by 6, and probability of no is what? It is 2 by 6. So it is square. So if you calculate this value, so this comes out to be 0.44. Now cool is coming 4 times. Cool is coming 4 times. Out of that, 3 is yes. So 3 times yes. The probability of yes is what? It is 3 by 4 square minus no is coming only 1 time. So this is 1 by 4 square. So if you calculate this value, so this value comes out to be 3.375. Okay. After that, we have to calculate the GI for the temperature. So we have to consider here now only the weighted average. Weighted average multiplied by GI. So what is the weighted average for the hot? So this is 4 by 14. Okay, multiplied by 0.5. So this value. Mild is coming 6 times. So plus 6 by 14 multiplied by 6 by 14 multiplied by 0.44, and the last value code is coming 4 times, so 4 by 14 multiplied by 0.375. So here only the weighted average multiplied by GI. So value will come out to be 0.44. Okay. So this is the value. Now the temperature is over. Now we'll go for the humidity. In humidity we have high and normal. So high is coming 7 times and normal is coming 7 times. In case of this high, 3 times yes. So 1 minus probability of yes is what? 3 by 7 square. 3 times yes out of 7 minus no is coming 4 times. So 4 by 7. No is coming 4 by 7. So this value comes out to be 0.49. Normal is coming 7 times. Out of that 6 times yes. So 1 minus probability of yes is 6 by 7 square minus 1. No is coming 1 times only. So 1 by 7 square. So this value comes out to be 0.24. Okay, this value comes out to be 0.24. And now we have to calculate GI of humidity. So here only weighted average multiplied by its GI. So 7 times, so 7 by 40, and its GI is equal to 0.49 plus again 7. So 7 by 40 multiplied by its GI. So the total value comes out to be 0.37. Okay, so GI for humidity it comes out to be 0.37. Now it is for the wind. So the wind here it is weak and strong. Strong it is coming 6 times and normal it is coming 8 times. So in strong 3 times yes. So probability of yes is what? It is 3 by 6 square minus no is also coming 3 times. So it is 3 by 6 square. So if you calculate this, so this comes out to be 0.5. And in normal is 8 times. Out of that 6 times yes. So 1 minus 6 by 8 square minus no is coming 2 times. So 2 by 8 square. So if you calculate this value, so this comes out to be 0.38. Now we have to find out the GI for the wind. So this is weighted average multiplied by GI. So what is the weighted average for a strong? 6 by 40. So multiplied by 0.5 plus normal it is 8 times. So out of 14 multiplied by its GI is 0.38. And the answer for this is 0.43. So we have calculated the GI for all the columns. So see the GI for weather. So this is 0.34 and GR for temperature is 0.44. GI for humidity it is 0.37 and GI for the wind is 0.43. Now if you remember, in case of the information gain we have selected the highest value for the information gain, that as the decision node. In case of this GI we have to select lowest value. Okay, so for GI you select the lowest value. So out of this weather is having the least value. Okay, in case of the GI we have to select the least value, while in case of the information gain we have to select the highest value. So here weather is having the least value of GI, so we will select the weather. So in weather we have sunny, cloudy and rain, and if you check the cloudy, so for cloudy all our yes are there. So now this is closed now. Okay, this path is closed. Now only sunny and rain is remaining. So we'll again repeat the same procedure for sunny and rain. So now select all sunny. So in sunny we have 2 yes and 3 no's. So total observations are 5. So 2 yes and 3 no's. So 1 minus probability of yes is now here 2 by 5 square minus no's are 3. So 3 by 5 square. Okay. So we can calculate the Gini index for the parent node. Okay. Okay. Though it is not required, we have to calculate this. Okay. We want only this part only, the below part. Okay. We have to calculate the GI for all these 3 parts. Okay. Now for the temperature. Okay. So temperature. Now here in this case the temperature. So hot, mild and cool. Hot, mild and cool. So hot is coming 2 times, mild is coming 2 times, and cool is coming 1 times. So yes, in hot 0 times yes. So 1 minus. So we don't have to take yes now. We will take no. So no is coming 2 times. So 2 by 2. Okay, square. So this is 0. Now in mild yes is coming 1 time, so 1 minus 1 by 2 square, minus no is also coming 1 times, so this is 1 by 2 square, so this comes out to be 0.5. Now in cool it is only 1 time, okay, so that is 1, yes is coming 1 time, so 1 by 1, okay, so this becomes how much? This becomes 0, okay, this becomes here the 0 value, okay. Now how to calculate the GI or GI for the temperature now? So GI for temperature is what? Weighted average. So weighted average for hot is 2 by 5. Total observations are 5 now. Okay, the total observations are 5 now. Initially it is 14. Now here it is only 5 multiplied by 0. So then this is mild is coming 2 times. So 2 by 5 multiplied by 0.5 plus here it is cool is coming only 1 times. So 1 by 5 multiplied by 0. So if you calculate this value, so this comes out to be 0.10. Then humidity, in humidity we have high and normal. High is coming 3 times and the normal is coming 2 times. Now in high 0 yes and the no is coming 3 times. So 1 minus, we don't consider the probability of yes, consider probability of no now. So 3 by 3. So if you consider this, it becomes 0. Okay, so here if one data set is 0, so then GI is also 0 and entropy is also 0. Okay, so here also one data set is 0, so in this case also you will get the GI for the normal is equal to 0. Okay, then here GI for humidity, how to calculate the GI for humidity? So weighted average for high, so this is 3 by 5 multiplied by 0 plus here 2 by 5, that is for normal 2 by 5 multiplied by 0. So this comes out to be 0. Then the third one is wind. So in wind we have strong and weak. The strong is coming 2 times and weak is coming 3 times. So 1 time yes. So 1 minus probability of yes is 1 by 2 square minus probability of no is also 1 by 2 square. So this becomes how much? This becomes 0.5. Okay, so we'll get 0.5 here. Then in weak, yes is coming 1 times. So this is 1 by total occurrences are 3, so 1 by 3 minus 2 by 3 square. Okay, so this comes out to be 0.44. Now if you calculate the GI for the wind, so only weighted average multiplied by its GI. So here it is 2 out of 5. Okay, now here it is only 5, 2 by 5, 0.5, the plus weak is 3 by 5 multiplied by 0.44. So this comes out to be 0.47. Okay, the final answer is 0.47. So we have now for the second, when we consider the sunny, okay, that means 5 observation. So we have to select out of temperature, humidity, wind, we have to select the decision node. We have the GI is equal to 0.10 for temperature, 0 for humidity and 0.47 for the wind. Now in case of GI, select the least GI. Okay, select the least GI. Okay, now this is for humidity. So after sunny, what we will select? We will select the humidity. Okay, in humidity we have, if humidity is high, the answer is no. In humidity, if the humidity is low, the answer is yes. So directly we'll get the answer here. So the decision tree get closed now. Now only rain is remaining. Okay. Now follow the same procedure for rain. So select all the rows containing the rain. So we have 3 yes and 2 no's. That is again rain, 5 occurrences of the rain. Out of that 3 yes. So 1 minus 3 out of 5 minus 2 out of 5. Okay, then calculate the GI for the rain. Okay, so in case of the Gini index, the calculation for parent node, it is not that much important. Only calculation for the children node, GI for the children node is important. Okay, now in temperature, so hot is not there, so we will cancel it out because it is all 0 0. We have only mild and cool. Mild is coming 3 times and cool is coming 2 times. So 1 minus yes is coming 2 times. Out of 3, 2 yes. So 2 by 3 square minus 1 by 3 square. Okay, so if you calculate this answer, so the answer will comes out to be 0.44. Then cool is coming 2 times, 1 yes and 1 no. So this is 1 by 2 square minus 1 by 2 square. So this comes out to be how much? This is 0.5. What will be the GI for this the temperature? So here 3 by 5 multiplied by 0.44 plus cool it is 2 times. 2 times out of 5 multiplied by its the Gini index. So this comes out to be 0.47. Okay, then the for humidity. So okay, so for humidity, the high is coming 2 times and normal is coming 3 times. One yes and one no. So 1 minus 1 by 2 square minus 1 by 2 square. So this comes out to be 0.5. Then in normal, 2 yes. So 1 minus 2 by 3 square minus 1 by 3 square. So this answer comes out to be 0.44. 0.44. Now what will be the GI for this humidity? So weighted average for high. So this is 2 by 5 multiplied by GI for high is 0.5 plus normal is 3 times. So 3 out of the 5 multiplied by 0.44. So in this case, the answer will come as a 0.47. Now let us go for the wind. The wind is coming. Wind we have strong and weak. Strong is coming 2 times. 0 yes, and no is 2 times. 0 is and no 2 times. So 1 minus. So we will not consider 0. 1 minus. This is 2 by 2 square. So this becomes 0. Here it is. We will not consider no. 1 minus 3 by 3 square. So this becomes 0. Okay. So now we have solved this one. Okay. So now we got the GI for the temperature. It is 0.47. This is also 0.47, and this is 0. Now in case of the Gini, we have to select the least GI, and that node that data set we have to consider as a decision node. Now in this case, this is a wind. So we have wind now. So wind, when it is strong, it is no, and when it is weak, it is yes. Okay. So similar to the entropy and the information gain, we got the same decision tree, and we got the same decision tree using the Gini index. So in what is the difference between this entropy and entropy information gain and Gini index? So in the previous problem, we have calculated the entropy, then we have calculated the information gain. While calculating the information gain, we have minus that weighted average multiplied by entropy of the children from the parent node. Okay. So while calculating the information gain, we have minus the weighted average multiplied by its entropy from the parent entropy. Okay, but we have not done that in the Gini. In Gini, we have only calculated the value of weighted average multiplied by its the Gini index. Okay, so we are not minus anything in the Gini index while calculation of Gini index. Okay, and we have solved the same problem, and we got the same answer using Gini index also. So this problem is also important. Okay, so the questions will be from 8 to 9 marks. The last questions will be on the PCA. So that is the principal component analysis. So they will ask you to calculate the PC up to 4, the 4 iteration, that is PC4, that is PC1. We have to calculate PC2, we have to calculate PC3, and we have to calculate PC4. Okay. So these 4 indicates what we have to calculate the principal components up to 4, up to the 4 values. Okay. So here the problem is given. So first, the first step is to calculate the mean. So calculation of mean for this is x1. So this will get here x1 bar, and for x2 will get the 11 plus 4 plus 5 plus 14 divided by 4. For x1 bar, it is 4 plus 8 plus 13 plus 7 divided by 4. So we'll get x1 bar as 8 and x2 bar as 815. Second one is the covariance matrix. So covariance matrix is something like this: x1 x1, here it is x2 x2, here x1 x2, here x2 x1. Now the covariance matrix for x1 and x1 is what? Is the formula is what? 1 upon n minus 1, x1 minus x1 bar, okay. Now here both, this is x1 minus x1 bar, x1 minus x1 bar, 1 upon n minus 1. Okay. So here x1 minus x1 bar means what? x1. So this is x1, 4 minus here this is 4 minus, for first value 4 minus 8, here this is 4 minus 8, so 4 minus 8 square. Second value is 8, so 8 minus 8 and 8 minus 8. So the third one is what? 30. So 13 minus 8, 13 minus 8. So 13 minus 8 square. Last value is 7. So 7 minus 8, x bar is 8, and 7 minus 8. So the last answer, and divided by 3. The n is equal to how much? This is 4. So 4 minus 1 divided by this. So we'll get a covariance matrix of this one, x1 and x1. When it is x1, x2. So x1 minus x1 bar, x2 minus x2 bar. Okay, you first consider x1 minus, first bracket is x1 minus x1 bar, and the second bracket is what? x2 minus x2 bar divided by the 1 upon n minus 1. So here for calculation, this is for x1. So for a calculation of this x1, this is the 4. Okay, this is 4 minus 8. X1 is 4. And x2 is what? 11. So 4 minus 8, 11 minus 8.5. This is x2. This is x1. Then this is x1. X minus x bar. x2 minus x2 bar. x2 bar is 8.5. So then using this the same formula, you have to calculate the covariance matrix. Okay, so the final covariance matrix comes out to be 14 minus 11 minus 11, 23. So this is the final answer. Okay, and this formula you have to remember. Okay, so the first value minus x1 bar, the second value minus x1. If it is x1, it is x1 bar. If it is x2, then it is x2 bar. Okay. So if it is x1 minus x1 bar, x1 minus x1 bar. When it is x2, for this, how we can write down the formula? So for this, it is x2 minus x2 bar, x2 minus x2 bar. Here it is x2 minus x2 bar, and then x1 is there, so x1 minus x1 bar, and divided by n minus 1. Okay, so we have to find out the covariance matrix like this. Okay, so second step, then we have to find out the eigenvalues. How to find out the eigenvalues? So for that purpose, we have to use s minus lambda I. So yes, we have already calculated 14 minus lambda minus 11, then minus 11, 23 minus lambda. Then this cross multiplication, so 14 minus lambda, 23 minus lambda, minus of minus 11 minus 11. So lambda square minus 37, 301. We got this equation. So find out the roots of this equation. So the first root is 30.38 and the second root is 6.6. So the first is our lambda 1, second one is our lambda 2. So these are two eigenvalues, lambda 1 and lambda 2. So now we will calculate the eigenvector. Eigenvector is what? S minus lambda I multiplied by the unit unit vectors, unit matrix. So S minus lambda U is equal to the zero matrix, that is the unity matrix. Okay, 0. So U1, U2, these are our eigenvectors, equal to 0. So 14 minus lambda, the same matrix from the beginning. 14 minus lambda minus 11 minus 11, 23 minus lambda, U1, U2, that is equal to 0. Okay, so same matrix here, 0, 0. Okay, 0, 0. So here cross multiplication. So 14 minus lambda U1 minus 11, 14 minus lambda U1 minus plus minus 11 U2. Then minus 11 U1 plus 13 minus lambda U2. So we got the first equation, second equation. So you convert our first equation. This equation gives U1 by 11, U2 by 14 minus lambda. We have to calculate U1 and U2 values. We have to find out this value for this unit vector. Consider t is equal to 1. So U1 is equal to 11t. So this is U1 is 11, and this U2 is what? 14 minus lambda. Okay, we got this one. After that, once you got you got this U. So divide this by unit eigenvectors. So how to find out the unit eigenvectors? So 11 square plus 14 minus lambda 1 square. So here we are considering lambda 1 is equal to 30.38. So 14 minus that value So we'll get that particular value as a 14 minus lambda. Okay, lambda 1 value. Find out the E1 and divide this 11 by that unit eigenvector value. Then 14 minus lambda 1 we are considered divided by that. So we'll got the first eigenvector E1. Similarly, we have to put here lambda 2. Lambda 2 value is 6.61, and then we have to again find out the its unit vector. We have to find out the value of E2. So we'll get E2 is equal to 0.8308 and this value. So this is our second eigenvector. Once we will get this one, so we can find out the percentage of variance also. So lambda 1 is equal to 30. So 30 divided by 30 plus 6. So we get 82% variance for lambda 1 and 17.87% variance for the lambda. So that means the lambda 1 is will be dominant in the whatever the principal component we are getting using lambda 1. So that is dominant because it is having a variance of 82%. Okay, so now once we have found out the eigenvector, so we have to find out the first principal component. How to find out the principal component? So E transpose x1 minus x1 bar, x2 minus x2 bar. So E transpose means this is 0.5574 minus 8303. So that value. So now it is transpose. So vertical converted into horizontal transpose. Then x1 minus x1 bar. So 4 minus 8 or cross multiplication. So 0.55 multiplied by this minus this plus minus of this multiplied by this. So we'll get here minus sign. So here this value is the first value, that is 4 minus this is the average value of x1 bar. This is x2 value and x2 bar. Okay. So we'll get minus 4.3 as a value. Okay. So this is our first principal component. Similarly, we have to do for 8. So in second time, this is 8 and 8. This will remain 8 and 8.5 remain constant. These two values will remain constant. Only this value will change. Then next time this is 8 and x2 will be 4. The third time this is 13 and this is 5. The next time this is 7 and then 14. So this value 7 and 14, 13 and 5, x1 and x2. So we'll get 4 principal components: PC1, PC2, PC3 and PC4. So we got now 4 principal component here. Okay. So if you plot these principal components, so all the data here, if you plot this E, so what we'll get here on the perpendicular so on this mean 8 and 8.5. So this is our 8 and 8.5, x1 bar, x2 bar. So if we plot 0.55, okay, 0.5574. So 0.5574, it comes something here only 0.5574. Okay, and the another is what? It is minus 8. So minus 8 value will come here. So we'll get the first value here. So E1, this is our first principal component. For second, it is positive 0.8 and 0.5. So 0.8 and 0.5. So we'll get here. So this is our second principal component for this is our eigenvectors. So this becomes our principal component. Okay, so that we can plot. But if you can solve the problem up to this PC calculation of PC components only. Okay, so you can end the problem here also, or you can go for plotting the data also. So this is sufficient. They will ask you to compute the principal components up to 4 values. Okay, PC1, PC2, PC3 and PC4. Okay, so these 3 problems are very important as far as the examination is concerned. Okay, so thank you very much.